Okay, we're going to go ahead and get started here. So, thank everybody. Last day of the show, so hopefully everyone's getting some good sessions in here and enjoying their time. My name is Scott Harold. I run product management for Red Hat's virtualization technologies. That includes KVM, Qemu, sVirt, as well as our Red Hat virtualization product. Everything up to where OpenStack starts, that's where I hand that off to a different team. But the enablement capabilities and some of the virtualization management products, I'm responsible for roadmap and product strategy, and I'm joined by my colleague, Prasad.
Prasad Pandit. My name is Prasad Pandit. I work for the Red Hat product security, and I primarily look after the virtualization security issues and the kernel security issues.
So today we're going to talk about some understanding the security risks and mitigation that can happen across your virtualization environment. Quickly, again, I'm the pretty face here, so I do the marketing and the high-level stuff, and I brought the brains with me to actually be able to talk about stuff and answer your questions that I'll just have to defer normally. So, but first, I wanted to just give a quick overview on the virtualization stack, how we perceive it, and how we see different attack vectors and how the scale of the problem can ultimately become an issue. So where we see the hypervisor stack is it runs within within Red Hat at least, and KVM in general, in both the kernel space and in the user space. Within the kernel space, we have the physical hardware, which is running the operating system. The operating system has its own kernel, in this case it's Linux. Within that, we have a module for KVM that runs effectively the hypervisor. It actually helps us do translation of the virtual hardware over to the physical hardware through the use of an emulator. In this case, it's actually the Qemu emulator, which is doing that effort to help us do the translation to physical hardware. And guests, of course, are supposed to run in isolation through that emulator. And within that, we have something that helps us manage this, the virtual machine manager, which in this case is the API layer of sVirt. So drawing this out in the components that we use with the Linux kernel is we have the virtualization hardware pass through the KVM module to physical hardware, as long as it has AMD-V or Intel is it VTX? Yeah, VTX or VTD. In some cases, we can do the physical pass-through of virtualization. And of course, that's been in any hardware that's been made over the last probably 8 or 9 years. One of the things that we have to take a look at is it's not just about a single server and protecting what's happening on one system. When we're running virtual machines, there's the concept that virtual machines can run on that single system. But when we look at an enterprise implementation, this is scaled out across a large number of systems, a large number of hosts that are constrained within clusters. Virtual machines can actually move across these hosts. So we have shared network and shared storage implications that we need to help protect across this overall stack. And if you're looking at virtualization and protecting virtualization within that single silo, you're missing the overall scope and potential of harm that can be done in one of these enterprise type environments. So to start off, I want to talk about just some of the types of virtualization threats that we see out there. One of the most common threats that we see is actually denial of service attacks, termination of guest resources, or flooding a system with so much CPU consumption or memory consumption that it prevents other things from operating. That's something that can happen outside of the virtualization layer. It can happen at application level, can happen at operating system level, it can happen at host level. Anybody that can prevent you from running or executing future virtual machines has effectively made it so you can't use a portion of that infrastructure. We also have memory corruption and memory leakage. And this is the ability to actually corrupt or be able to pull memory of the virtual machine from the host that it's running on. And how do we protect that from escaping the virtual machine and actually getting into the host to be able to access the host resources. So there's a lot of different things that we can do to help protect this, but these are the things that we need to be aware of, is making sure your processes are secured, making sure your memory is secured, especially if you're looking at doing live migrations. In our case, live migrations happen in an unencrypted format on what should be a private network. But while that's happening, that's exposed unless you're using TLS or some form of multi-layer security on the back end. That's happening in plain text, and your memory is actually going over the wire. So different things that you need to think about that help introduce why it's important to think about security in terms of scale. So when we're looking at the termination of guests, there's several different types of exploits that we can see. One of the first ones is a divide by zero error, which of course oftentimes enables us to escape execution and do.
It would crash the emulator layer, or it would crash the host layer, which will essentially bring down all of the guests which are running on the host, or all other services which are running on that host, if it's in the hypervisor layer or if it's in the kernel layer, right?
So we can also see infinite loops where people are just running code that's constantly executing and consuming CPU or memory resources.
Again, if these are the issues which happen in the emulator layer, that's the Qemu layer or the kernel layer. If a guest is able to trigger an infinite loop in the emulator layer or in the kernel layer, it can essentially consume the CPU cycles or other resources on the host, which will affect the services which are running on the same host, right?
Yep. And then the last one is null dereference and invalid memory access, and I believe this also has potential to crash and escape.
Yep. Null dereferences are particularly bad because they could lead to arbitrary code execution on the host.
Yeah. So a lot of these will either prevent the virtual machine from running, or actually, in some cases, enable us to escape, in which we can consume resources on the host itself and effectively shut down an entire host. And if we can escape or exploit a guest on one host, it's entirely possible we can do so on another. And we can actually take out large portions of the environment by being able to take advantage of these denial of service. The other one that we wanted to talk about was memory corruption and leakage. And we have certain things that can provide buffer overflow, memory corruption. This is something that happens in applications all the time, in operating systems all the time. It's probably one of the most common exploits that's existing out there.
They are particularly bad because they could lead to escalation of privileges, especially the buffer overflows, which could, from one guest, you are essentially able to access maybe resources of other guests or files and services of which are running on the same host.
Yep, we can get out-of-bound reads, so we can actually gain access to memory and information.
Yep, you can read arbitrary, not necessarily code, but arbitrary data on the memory, which could be of other services or which could be on the same host of the same service.
And then you mentioned the privilege access is once you are actually able to escape your own privileges and run as a higher level of privilege, a higher privilege user, you can effectively have access to the entire infrastructure, the entire environment, and pretty much have your whole way with everything that's in the system. And again, these are risky because these can happen at any layer. Applications are exploited for buffer overflows all the time. We're still finding buffer overflows in operating systems.
Yep.
Even in the hypervisor layers, we're seeing these types of attacks being carried out fairly regularly.
That's right.
And then one of the most dangerous types of vulnerabilities are the guest-to-host escapes, and these are ones that get a lot of noise and attention, especially in the virtualization space. Sometimes to the point where they kind of embarrass the entire security community and they do a whole bunch of PR and create logos for them like Venom. Venom was one that actually used incredibly old hardware that's really not used in a large majority of instances anymore, but was enabled in every virtual machine, a floppy drive controller. You didn't even have to have a floppy drive configured or connected to the virtual machine. The code was there for the controller component itself. The chip, the i440 chipset that we were using had that built in. People were able to exploit this old hardware, this old code that probably hadn't even been reviewed in years because it's a floppy drive. How much future technology can you build around that? You can't do it. The other one, Dark Portal, was a buffer overflow on doing VGA read writes. Again, we're looking at VGA technologies. We're looking at floppy drive controller technologies that people were able to exploit and sneak under the covers that ultimately blew out to be issues that let us actually get away from the guest and potentially execute code at the host level. So very, very risky because that's what virtualization is supposed to do. It's supposed to abstract your virtual machine from the hardware that it's running on, from the host that it's running within.
That's right. Yep.
So that's great. We got all these scary things that are coming out there. We've got snakes that are going to bite you, and massive PR efforts going on around it. So what are some of these things that we can do to help mitigate these threats and these risks? And that's where I'll turn it over to the person that's much smarter than me in those instances.
Thank you, Scott. So before we kind of look at the mitigation techniques which are there to prevent the effects which we'll see, we need to understand the complexity which virtualization layer brings to the whole setup. So before, if we consider a non-virtualized environment, we have individual servers running individual processes or individual services. It could be a web server, it could be a data server, it could be just hosting provider hosting multiple services, right? But when we talk about virtualization, we combined all these services on one server, right? It could be a one server with say 64 processor and 300 gigs of RAM, which will be running all these services and from one server. So even the innocuous or less effective issues like say infinite loop, which would hamper only one system in non-virtualized environment, could hamper all other services which are hosted on that server, right? So what we need to contain the effect of these kind of issues is, we need to kind of isolate the resources and control the resources which are assigned to these processes on the host, right? That's where the control groups kernel feature comes into picture. The control groups provide a facility which it's a kernel feature which provides a facility to group processes on the host, right? It's a simple mechanism which allows you to group individual processes on the host which are running on the host, and then on top of those groups there are facilities which provide you to control resources which are allocated to that group. There is a kernel scheduler which can schedule groups of processes together. There is a CPU accounting feature or CPU sets feature which allows you to allocate individual CPUs or groups of CPUs to groups of processes. There is a memory controller or block IO controller which can allow you to limit the block IO count or number of memory bytes which are allocated to these groups of processes.
Yeah, in addition to that, there's control groups for all four of the core resources that can actually be exploited. So C groups can help you not only create groups or constrain to groups of resources, it can also do fractions of resources. So making sure one virtual machine can't access more than half of the CPU that is allocated. Making sure that the storage IOPS or the storage throughput don't exceed a certain value. Same thing from the networking standpoint. So from the four core resources of CPU, memory, disk, and network, you have a way to protect it so no one workload, no bad developer can write some code that doesn't work as expected and get you into a place where you're DOSing yourself or consuming all these resources and causing issues at a wider scale across your environment.
That's right. When you have a subset of CPUs or a subset of memory which is allocated to say a guest, and if a guest is able to trigger issues like say infinite loops or memory leaks on the host, it will be contained to that subset of the entire resources. It won't affect the entire system resources, right? That's how we contain or limit the number of resources which are allocated to individual guests. And there are user space tools like in these days systemd has, with the rework that has been going on into control groups, systemd comes with integration with the control groups feature, and when you boot a systemd enabled system, it automatically creates three control groups on the system, which are machine, then system, and the user level processes. So machines are essentially the control groups for containers and virtual machines, whereas system is the control groups for system services, like say it could be FTP server, it could be a DNS server, it could be other servers, MySQL server, and the user control group is essentially for the user process, individual user processes. Right? sVirt also comes with this integration, and it automatically creates, when you run a guest, it automatically creates a control group feature in the virtual file system, and wherein you can control the allocated resources per guest in that system. SELinux is another very versatile tool which is used to isolate processes and contain the effects of bad issues which occur on the system.
That's why I run set and force 0, right?
Yeah. So SELinux allows, what it does is it labels each process and each file or each device on the system, and then it provides a mandatory access control mechanism to limit access from one process to the respective files on the system. So unless that matching happens with the labels, a process or a guest is not able to access different resources which are there on the system. So imagine a situation where you have multiple guests running on the host, and one guest is able to trigger an issue wherein it could lead to say directory traversal on the host, right? But because so a guest is going to be generally run by as a Qemu user if you're running by sVirt, right? And if it's via directory traversal, it tries to access other files on the system. SELinux mechanism will, or the mandatory access control system will prevent that kind of access, and it will limit the impact of the issue to only accessing those files which are owned by the system user, that is Qemu user, right? It has two modes of operation. One is enforcing, one is permissive. Enforcing is usually the default, but many times we have observed people sometimes disable it. In permissive mode, it does not implement the mandatory access control, but it logs the denials which have occurred in the audit file, right? The rules have, how do you operate? Okay. So the typical SELinux policy or the label has 4 parameters. One is a SELinux user type, then SELinux role type, then this the file type or the content type, and then it also adds a multi-level security index to the label, by which you can, within the given label, you can have multiple levels of access control. Like for example, if you have, say, Qemu user hosts, or Qemu user has or hosting multiple files of multiple guests. So one guest should not be able to access files which are owned by different guests, right? So for that kind of access control, it has multi-level access control index attached to the label. It restricts the access based on the role and the type of the resources. Yeah, from there we come to the next technology or the next tool, which is used to further isolate the guest from individual guests other which are running on the host. So what sVirt does is, sVirt is a framework which is integrated in the libvirt system. What it does is it capitalizes on the multi-level security index of the SELinux, and it dynamically creates a multi-level security index and multi-category security index, and it assigns those index to the guest process and the image file which is there on the host. By which, so if imagine a situation where a guest is able to trigger an issue where it could access host files, it would not be able to access host files which are not owned by the same guest. Right? It would not be able to access files which are owned by a different guest running on the same host, or say different user running on the same host.
Yeah, and sVirt is what ultimately helped protect Red Hat technologies with the dark portal and in particular the Venom vulnerability. Is even if users were able to escape the virtual machine, the context was locked down. It could only operate in, every virtual machine is essentially a process. So within the Qemu process running that, the user that was running that process and the SELinux label and sVirt label that was applied to it. So if they tried to access anything that didn't have that exact match, it instantly would have denied access.
That's right. So SELinux further these days also allows a sandboxing mechanism for user level processes. It comes with the sandbox tools which has its own policies wherein you can run your own process. Like say if you want to run a browser, Firefox, or different applications, you can do sandboxing on those applications as well. It again, sVirt capitalizes on the multi-category security index of the SELinux. libvirt, so this is a graphical notion of how libvirt does it. So libvirt creates 2 guests, and each guest is assigned a security index, say MCS1, and the other guest image is assigned MCS2. So this guest is not, even if it tries to access other images on the same host, it would not be able to access, because SELinux will prevent, or sVirt will prevent that kind of access based on the security index which is assigned to the label, right? The next tool which provides further sandboxing or isolation of the processor is the Seccomp. Seccomp is, the basic idea of Seccomp is every process does certain system calls on the host. So if we could limit the number of system calls or the kinds of system calls that are accessed by a process, we could reduce the attack vector or the damage it could cause, an issue could cause in that kind of applications, right? So it's a recent development in Seccomp. What it does is it uses the Berkeley packet filter mechanism, which is in the kernel. It uses that mechanism to filter out system calls which are made by an application, right? So if by that way, an application is only restricted to limited number of system calls, and if there is an issue within those system calls, only then it will cause a problem to the host or problem to the other processes. Otherwise, it would not be affected at all. It has a dual process approach in a way that there is a trusted process which is able to access all system calls on the host, and there is a client process or a sub process which is restricted. So all system calls which are required by a non-trusted process has to go through a trusted process, and that is where the filtering mechanism happens, or that is one way of doing it. And recent Qemu version, the upstream Qemu versions have the integrated support for the Seccomp mechanism. You can enable Seccomp mode 2 in the configuration files, and it does facilitates sandboxing of the Qemu guest. Okay, so takeaways are: we need to minimize the kind of access that is given to the guest. We have to disable or restrict privileges given to each guest, right? And we have to contain each guest within a sandbox of least privileges given to each guest. SELinux is the best tool so far which provides this kind of mechanism. There are other Linux security modules like AppArmor or SMAC which provide similar functionality, but SELinux has been the best so far. And keep the guest and the host systems updated all the time, right? That's important too. Yep.
That's the presentation that we have. We wanted to leave a lot of time for questions. We know that this is typically a very popular area around virtualization, and there's simply no way for us to prepare a presentation that can cover every facet. So we do have the right people here. If you have questions, we planned plenty of time. Yes. Yep. We've got a microphone for you right here. So if you don't want to be heard, then we'll repeat it for you. But
oh, okay. Can you hear me?
Yep.
So I'm interested in the multi-classification security via SELinux.
Right.
Problems I run into, it seems like documentation in that area is hard to find. I mean, anything that's usable by mere mortals seems to be a little hard to find.
That's one of the jokes that we actually have within Red Hat ourselves, is there may be 7 or 8 people in the entire company that actually understand it fully to the level that is needed to be able to effectively build it. And those are the people that are actually building it, building the default policies. We are aware that we need to do better documentation and better discussions of how SELinux can help protect users. It's one of the things that we will be focusing on from just a general product and documentation standpoint, because we feel that this is incredibly powerful, and it does need to be exposed and brought to the forefront. It is good differentiation for the KVM technology stack that Red Hat can help provide, and we want the world to know about it.
So where do I go look?
We are in the process of improving our documentation processes around it. So you can go to probably what's your security blog?
There is a Red Hat Linux documentation which has a lot of details about multi-level security index and multi-category security index of the SELinux policies, and it is quite detailed. But yeah, there is a lot of room for improvisation as well. That's true.
A lot of it is in RHEL documentation around SELinux in general, and sVirt, we know there's a gap around the additional encapsulation that sVirt can provide.
I have an application that has some calculations that need to be protected from the root user, specifically the root user on the host operating system. I understand that SELinux can be used within the container, within the VM, in order to protect the calculation. But my risk assessment shows that the root user also needs to be isolated from these types of calculations, as well as the data on rest within the virtual system itself. Is there any way that that SELinux is, and some of the other techniques that you mentioned, is there any way that that can be used in order to protect the root user? And at what level? Common criteria type security controls, those types of things.
So when you say when you say calculation, you mean the calculations which are running in the guest memory?
Yes.
They would not be generally visible directly to the root on the host, but if the data files are saved on the host, yeah, of course, root being the root user, they will have full access to the files. Right?
And so certainly running the calculation is an area of exposure that I'm concerned with, but also the data at rest. So I can go through, and a good system administrator should be able to do a lot of binary analysis and things like that on what's running on that particular VM and be able to extract information out of it.
But that would require an access to the running guest. That's the memory of the running guest, right? To the root user or any other user for that matter.
But the constants and the actual application that's being run is still within the virtual machine itself.
Right.
Right? So if I'm the root user on the host operating system, I should be able to go into the files of the virtual machine and pull this information out.
Yeah, that's, I think, an area that's still, I don't know that SELinux would be able to prevent the root user of the host.
That's true, because root user would be the user who would set the policies, right? Or the administrator would be the person who would set those kind of policies.
Yeah, so, I know that there are some technologies coming in hardware that we are looking at from the virtual layer with either memory encryption, TPM, different things that can actually protect runtime data while it's being run and executed, even from the host itself. We are trying to work with the hardware partners doing the enablement of those technologies, typically at the processor level, but that's something that is still in the process of coming to market. We do have close relationships with Intel and AMD around their plans for their virtual TPM and their memory encryption technologies, but we're learning with them, and as soon as we have the enablement capabilities, you will start to see us doing some of that path, because that does provide that additional level of protection, particularly in our public sector where we see that strong demand. You mentioned common criteria, which is an absolute requirement from that, and we see a lot more around network multi-layer security in that particular space as well, where we have to go above and beyond what we're doing today from that aspect as well.
Okay, thank you.
Okay, if there are no other questions, then, got one, okay, we got one up front.
Do you find that there's any particular vulnerability associated with a specific function of the stack, like the Do you find that there's any vulnerability associated with specific functions of the stack, like hypervisor versus VM, anything to focus on that's different, or do these techniques all apply across the board?
Yeah, we really see
the issues can be seen across the board, because it's ultimately the similar kind of code which is running the different systems. So the similar issues can occur at different levels, but they have different impact. Like if you have an issue in the hypervisor layer or the kernel level, it will have impact towards other guests or other services running on the host as well. Whereas if you have an issue in the Qemu layer, which is in the user space, it will only affect the particular guest that is running.
And if you have something that's within the guest, we have those protections that prevent that from escaping. There are more common types of attack vectors than others. The buffer overflow. Every piece of software is potentially vulnerable to that. That's what we see a large volume of. And when we get specific and detailed into exploiting a floppy drive controller, that's something that is very specifically targeted. It doesn't happen often, but the impact is often much larger than some of these smaller ones that can happen with an application or
as far
guest
as
stacks.
the issues relating to the memory go, there are different mitigation techniques which are specific to those layers. Like for example, in Qemu recently they have introduced the memory guard pages technology. So they add a specific memory area. If you exceed, or if the read and write operations exceed those limits, it would result in crashing the Qemu guest, but would not result in exploiting or executing arbitrary code on the host. So those kind of technologies are specific to the layers, but when you say a guest is able to escape, or guest user is escaping from the guest to the host, then we need different mitigation techniques like SELinux to contain the impact on the rest of the resources, right?
One up front here.
Just quickly, I wanted to mention that there was a session called Security Enhanced Linux for Mere Mortals. Unfortunately, it was on Tuesday. I don't know if you had a chance to get there, but we'd be happy to, if that wasn't, work with you and figure out how to get you that information.
All security sessions have been recorded and will be able to be accessed after the fact as well.
That is true, but this was a best of session,
Oh, okay.
so I don't know if it was recorded. We'll find out.
Josh?
Okay, so the comment from Josh Bressers, who's security product manager, is that that's been recorded in the past, and we should be able to find it on YouTube, but we can connect and help you there.
How do we get one of those presentations that I can just repeat over and over and never have to do a new presentation every time? Get into security? Okay, well, enjoy the rest of the day, and
Thank you so
everybody here, enjoy your holiday weekends. Thank you.
Thank you.